So the topic of my talk is a bit controversial: multi-threading in JavaScript. Seriously? A little bit about me. Who am I? I'm this guy eating sweet buns in Hunza. I like playing video games a little bit, and so I sit around 12 hours a day. So that's why I have to stay fit. I love JavaScript. That's the around 90% of my day. I talk about JavaScript, I search about JavaScript, and I ask questions and reply to some. So as you can see, all of my skills revolve around JavaScript. It's React, TypeScript, but now it doesn't really matter what it is, which framework, which library it is. So yeah, I have total 3 years of experience professionally working. I've been working even before that, but that doesn't count in professionalism. I've been working for some small university stuff, but that's a different thing. I've been working for very good organizations. You can see some of the known logos here. Currently I'm working for JSDive. So there is a good news and there is bad news. So I have only 25 minutes to cover all the things, so let's throw both together. The talk I'm going to give you today, it's not platform specific. It's not about you'll be applying in any Angular, React, but it's something, it's more of a mindset. It's more of a solution to the problems we are having now. So that might change a little bit of your mindset or the way you write code now. But the downside to this talk is that it's more theoretical. I cannot show you threads spinning around the room, so it's more theoretical. So back to the start. Event loops, in a nutshell, it's how it works. So there is so many pieces missing, and this is not that simple. But if you guys want to dive a deep, there is a link to the standard talk of the community, Robert Phillips. What the heck is event loop anyway? So do check that out. I'm not going to cover event loop, but a small story that all the async task goes to the callback stacks, and all the events come from the event queue and stuff, and it keeps happening. But the problem lies on this side where the call is not async. The call is sync, and you have to process it anyway. On the single thread, it will just choke the thread. That is the problem with JavaScript currently. And most of the multi-threaded guys just claim that it's single threaded. I'm never going to write the code. So it's a model difference, nothing else. It doesn't really make that bad. So the problem is there are sync operations in JavaScript. We cannot ignore that. We cannot just walk around something like, we cannot move around it. Sync operations can choke the UI thread, especially when you are not using your background as white thing. You don't know what's happening in the background, especially when you are using particle.js or green sock animation or some kind of animation that is running on your JavaScript thread. So it will completely log the thread, and all the user experience will go completely crashed. It will look so pathetic because you are actually doing the data thing, the UI thing, animation thing, transition thing, everything on the main thread, and main thread will get choked. So this is a problem with JavaScript currently. So there are workarounds, say animation workerlet. You should be doing that on a different thread, but I don't know, people in Pakistan do consider this thing, but we have a frame budget of 16.66 milliseconds. So you have to keep up with 16.66 milliseconds. You need to watch your operations. Are my operations really that sync that I can keep up with this frame budget or not?
Same demo again. Click the button, and it blocks rendering. It blocks the tab in the same way a plain while loop did. Very different from set timeout before. So promise callbacks are async, fine. But what does async actually mean? I mean, all it means is that they happen after synchronously executing code. So that's why we get yo before hey. But just being async doesn't mean it must yield to rendering. Doesn't mean it must yield to any particular part of the event loop. We've looked at 3 different queues so far. We looked at task queues, animation callback queues, which is where request animation frame callbacks happen. And now we're looking at microtasks. And just to make your lives a little bit easier, they all are processed very subtly differently. Like we've seen with task queues, we take one item and we take one item only. And if another item is queued, it just goes to the end of the queue. Fine. Animation callbacks, they happen until completion, except ones that were queued while we were processing animation callbacks. They are deferred to the next frame. Microtasks, on the other hand, they are processed to completion, including any additionally queued items. So if you are adding items to the queue as quickly as you're processing them, you are processing microtasks forever. The event loop cannot continue until that queue has completely emptied, and that is why it blocks rendering. Sorry, I get really excited about this stuff. I hope other people are excited about this as I am.
Okay, he's talking about the microtasks. If you are running your things in promise-based and you are spawning too many promises, that there is more likely a huge chance that you will just stuck your loop and things will go completely dead. But the good news is it's not a JavaScript problem. It's a model problem. JavaScript is concurrent. We all know that. So it's a model. We chose it by our own decision. So it's not a JavaScript problem. It boils down to concurrency and parallelism problem, if you see. So Rob Pike is a huge name when it comes to board level stuff. So he says parallelism is about doing multiple things at once, and concurrency is dealing with multiple things at once. So I remember some years ago when I was studying, my professor asked me a question: how many things does a processor do? And I was like, so many things. Actually, the processor does only one thing at a time. So this is concurrency is all about. I'm not talking about the multi-core systems or multi-thread. I'm not talking about that. I'm talking about the P2 systems. So biggest title, typical methodologies of handling long-running sync operations. How does other platform do that? Android is handling multi-thread, and I think Swift is also handling stuff, but how are they so smooth on their transitions and animations and their UI? So most of the time, other platforms enforce you to run your leggy script in a separate context, in a separate environment. So that's why the animation is mostly done on the main thread. So that's why those platforms or those UIs are very smooth, because they are not doing mapping and mapping and stuff or data related stuff on main thread. So yeah, as you can see, it's a time traveling task image I tried to make. So this task took around, every dot is a second. So the first task took 7 seconds and responded after this. For those 7 seconds, the thread was not logged. It was running, it was smooth still, because the sync task was being executed in a separate context. Do we have that in JavaScript world? Yes, web workers. Okay, it's not a JavaScript thing, it's a web specification, but we have the access, who cares? So we can do that. Web workers, what are they? Are they process, are they thread? There is so much controversy on this specification name. Some say this is a thread-like thing. Some say this is lightweight processes. And to me, because it's serialization and deserialization happening, so I find it more like a process than thread. But it's my word, so don't take it so seriously. Okay. So this is how easy to spawn a worker is. Like, you just do the new worker things, and we are safe for using the new worker constructor because it's 2012 specification and it has 96% coverage on all the browser, so you can use it now. And you just and the constructor establishes a post message channel between all the contexts. So you can just post the message from one context to another, and the other it said post worker.post message, and on the other side it received on message, hey kid. So easily, it just that simple. And all these things on this side is a completely separate execution environment. Okay, so if you are doing any kind of long running while loop or stuff, this is never going to choke your main thread. So how many workers are there? We are running out of time. There are so many workers in your web APIs. There are animation worker-led, and I heard about task work-led. I don't know what that is, but there are so many workers coming out now. there is service worker, and that has nothing to do with the web workers. Okay, the web workers then gets divided into two categories. There are dedicated web workers and shared web workers. The shared web workers, I'm not going to dive into that. I'll be talking about dedicated worker all the time, but it shares 99% of the concepts. So let's dive into that. Okay, the web worker is just a separate lightweight process or thread-like process. So it has no DOM access. It doesn't have some API. Just because it doesn't have DOM access, it also has some web API access like geolocation, local storage, and stuff like that. And you can do the canvas creation. You can do that by arrays. If you want to do some mathematics, you can do that. But you can print it from the web worker side to the main thread. Okay. So till now, are you with me, guys? Okay. So this is working in a nutshell. We want to keep our UI up to 60 FPS. FPS is frames per second. So okay, so we are just splitting our code over the dedicated web workers, and dedicated web workers are responsible for doing all the sync things on a separate context that won't choke our thread. So all the sync or FPS dropping operations should be done on the dedicated web worker. In action. Okay, so when how many of you guys have Angular background? So in Angular background, it fits a bit more nicely because we have service concept there. So just spawn these processes through a service, so it has their own context and separation of the concerns. Just do the polling and mapping stuff on one dedicated thread, maths and statistics on the other thread. Just keep it nice and simple. And if there are shared operation between all those stuff, if there is some formula or something happening similar, just do it on the shared operations, shared web worker. Okay. The goal is to put load of the main thread. The goal is not going completely multi-threaded or thinking like Java or C#. It's not the same thing. Okay, just if you have something that you cannot get rid of and you cannot just have any solution of that, but just put that off the main thread and it will just work like a charm. Distributing operation over less possible workers. Just because we have web worker doesn't really mean we start spawning web workers everywhere. Just keep them less as possible as they consume memory. Okay, make your application smooth and responsive. If you are using so much UI stuff, transition stuff, just use this from the first day, otherwise you will get choked in the end. So yeah, I think that's it. Benchmarks, it takes around 8 milliseconds, which is negligible to instantiation time, and this is not a bad trade-off, especially when you have to keep it on, and just don't do 3 or 4 iterations on a web worker. Doesn't really make sense. Do small things on the main thread, but still, if there is a big huge optimization or mapping or stuff like that that takes around more than this time instantiation time, just do throw it on a web worker. Communication latency is 0.5 millisecond, and latency is from one side to another, and it's echo message. Max size you can pass through one context to another is 1300 kilobytes. If you want to go crazy, you want to go even above that, you can use transferable objects. Those are also completely now I think they have more support now. I don't know what percentage, but you can use it. Communication speed is around 80 kilobyte per millisecond, and yeah, and these timestamps may vary on different browser because they have different implementations. Just do check them out. Performance tips: keep your message, especially when we use web worker, we just throw all the big nasty objects to the web worker. But before doing that, just do know that post message channel context, do serialize and deserialize. That is also a overhead of using the message channel, but there is a hack. Just do JSONify or do stringify and pass it through the contexts. It will optimize the speed, it will optimize the performance. And okay, transferable objects, done with that. Make your expensive network calls. If you are in a polling state and you have to keep your Redux up to date or any container up to date, and you are doing that every second, just do it in a web worker rather than doing it in the main UI. Okay, and unsubscribe all the listeners before killing your web worker. So can I use? Yes, dedicated web worker has around 96.1% of the browser support. Shared web worker has a little bit less, 41.1. It's not good. And a big announcement is Node. Node after 10.5 support the threads on threads natively. It's not the process, it's not the lightweight process, it's actually thread. So people running to other frameworks just for there are no thread support, don't have to. Okay, but it's on, I think, stage 1. Sooner it will be production ready, but at the moment it is not. So that's pretty much it. Thank you.